Hello viewers, welcome to my channel. My name is Mr.Adebanjo. In this video we are going to be solving this solid shape. We are going to be solving this solid shape on the screen right now, and using this question that was asked on this solid shape. And this video is as a result of a student who requested for this solution of this question, and we have solved like two questions related to this video. In the previous video, there was when we had a cone mounted upon a cylinder, and we also solved when we have an hemisphere mounted upon cylinder as well. So here we are told that the diagram shows a wooden structure in the form of a cone mounted on a hemispherical base. So the vertical height of the cone is 24 centimeters and the base of the radius is 7 centimeters. We have to calculate correct to three significant figures: the volume of the structure, then the total surface area of the structure as well, given that the pi is 22/7. So before we solve this question, we need to know the composition of this structure. What made up this structure? What and what are combined together to give us this structure? So what made up the structure, or the structure that were given to us, is that we are having a cone. There is a cone, and the cone is mounted upon an hemispherical bowl. So this is a cone. When you place this cone on top of this excuse me, on top of this cone, then that shape will be formed. So this cone, when it sits upon this hemisphere, this is an hemisphere. An hemisphere is the half of a sphere. So when you divide a sphere into two equal parts, you have an hemisphere. So that means this cone is placed on top of this hemisphere. So that means the circular base of this cone will sit upon the circular top of this hemisphere. So if you want to view it, that means this base of the cone will not be seen again when it sits upon this hemisphere, and that means the top of this hemisphere also will not be seen again. So, and that's how I want you to view it. So when this sits upon this, that means the base will not be seen again, it will be covered up, and that means the top of the hemisphere also will not be seen again, to be covered up by this cone. So having known the composition of the solid that we want to find is the volume and the hemisphere, so let's see how we can find the volume. Now that we understand the composition of this shape, that we are having a cone sitting up top, mounted upon an hemisphere, so let's see how we can find the volume of the structure, knowing that this is a solid shape. It's comprised of a cone and a hemisphere. So to find the volume of the structure, that will be volume of the cone plus the volume of the hemisphere. So the volume of this structure will give us the volume of the cone plus the volume of the hemisphere. And now we know the formula for finding the volume of the cone, and that should be 1/3 pi r square h. This is the formula for finding the volume of a cone. Then the volume of hemisphere is 2/3 pi r cube. 2/3 pi r cube is the volume of an hemisphere. So where h here is the height of the cone, and the r is the radius, the base radius of the cone, which is this ray on top of the cylinder as well. But we know that this circle you are seeing here is just for reference sake. If this cone sits upon this hemisphere, this circular base will not be seen again, but you are given so that will help you find the radius of the cone and that hemisphere. But I want you to see that this circular base you are seeing here is not going to be seen again, most especially when you want to find the total surface area of this solid shape. So let's go on with our the volume. I said the volume of this structure will give us the volume of the cone plus the volume of the hemisphere, and the volume of the cone is calculated 1/3 pi r square h plus 2 over 3 pi r square cube, which is the volume of the hemisphere. So something is common to this. Pi r square is common, so you can factorize. Sorry, not only pi r square. 1 over 3 pi r square is common. 1 over 3 pi r square is common to this and this, so you can factorize that out. So if you factorize 1 over 3 pi r square, we have h left here plus 2r left here. So I hope you understand how we got this. This 2 is this 2 that is there, so we have 1 over 3 here, 1 over 3 here as well. So if you bring that out, you are left with 2 here. Here you are left with h, then you are left with r here as well. So if you factorize 1 over 3 pi r square, you have this left. Now we can substitute the values now. So if you substitute correctly, you have 1 over 3 times pi is 20 over 7 times radius is 7, so you have 7 squared into the height of the cone is 24 plus 2 times radius, which is 7. So 7, we take care of 7 here, we are left with 7. So you have 7 times 22, that will give us 154. Then 154 over 3 times, you have 2 times 7 here, that gives us 14 plus 24, that will give us 38. So if you simplify this one further, this times this divided by 3, that should give us 1050.667 centimeter cube. So you have to approximate this to 3 significant figure, and that should give us a 1950 to 3 significant figure. So this is the volume of this structure, which is made up of a cone and a hemisphere. So let's see how to find the surface area of this structure, or total surface area of this structure. Whether surface area or total surface area is still the same thing. Now, like I was emphasizing the other time, that if you want to find total surface area of this structure, there's something that most of the students tend to make mistake on. It's not only on this, it's also same thing as when you have a cone mounted upon cylinder, or you have an hemisphere mounted upon cylinder. The same thing is going to apply here as well. I told you that this cone, when it is mounted upon this cylinder, then the base of the cone will not be seen again, and the top of the hemisphere also will not be seen again. Please, I want you to take note of this, because if you are looking for total surface area and you now go and add this, the area of this top, the area of the circular top of the cylinder, and that of the the circular base of this cone, which is also the top of the hemisphere. If you now go and add it to it, that means you'll be wrong. Why? Because when this cone sits upon this hemisphere, this circular base will not be seen again. This one I'm highlighting on, it will not be seen again. It's just like when you place and when you roof a house. So part of the top of the house will not be seen, because it's going to be covered up by the roof of the house. Is that correct? So technically, when this cone sits upon this hemisphere, then this circular base will not be seen again. It's not going to be a part of it. So definitely, if I want to find the surface area of this structure, or total surface area of this structure, all I need to do is to calculate the curved surface area of this cone, which is talking about the curvedness of this cone, then plus curvedness of the hemisphere, which is the curved surface area of the hemisphere as well. So that will give out the total surface area of this structure, or surface area of this structure. So this circular base, or the circular base of the cone, or the top of the hemisphere, will not be part of it. So therefore, but before we find the curved surface area of this, we need to find the slant height. We need to find the slant height of this, which is our L. So we need to find the slant height. When we get the slant height, because if you want to find curved surface area, if you want to find the curved surface area of the cone, we need the slant height of the cone, and that is our L. So when you not get that, then that's what we use to find the curved surface area of the cone. We cannot use the vertical height. That vertical height is used for finding the height of the cone. So that's vertical height is used to find the volume of the cone. So to find the curved surface area of the cone, we need to use the slant height, which is this L. And if you can see that we are having a right angle triangle here, so you can use Pythagoras theorem to find this L, this side L, and that's what you're having here, that the hypotenuse side, the square of it is equal to square of this side plus the square of the radius. So that should give us L square equals to 24 square plus 7 square using Pythagoras theorem. Thus you have L square equals to 24 square will give us 576 plus 49. So if you simplify that, will give us 625. Then our aim is to find L. Take the square root of both sides. L will be 25 centimeter. Now that we know the slant height of the cone, therefore the surface area of the structure, or the total surface area of the structure, will be curved surface area of the cone plus the curved surface area of the hemisphere. And what is the curved surface area of the cone? That is pi r L, plus the curved surface area of hemisphere is 2 pi r square. So curved surface area of the cone is pi r L, and the curved surface area of the hemisphere is 2 pi r square. Then from there, something is common here. We can factorize pi r. So if you factorize pi r, we have L plus 2r. So then we can now substitute the values here. So pi is 20 over 7 times radius is 7 into the slant I, which is our L, is 25 plus 2 times 7, which is the radius, multiplied by 2. So that 7 will take care of 7 here. You have 22 into 25 plus 14. 25 plus 14 is 39 times 22. That will give us 858 centimeters squared as the surface area of this structure. So if you understand what you have done, don't forget to subscribe to this channel. If you are yet to subscribe, just click the subscribe button, share this video, comment in the comment section of this video, and as you do so, may the good Lord bless you. I will see you in the next video. Bye.